different rates of change. When we talk about rate of change, it means one thing is changing while the other one is also changing. And one might change faster than the other, but the two of them are changing together. Like, if we have a connection like, when y is a function of x, you know the y is equal to change of differentiation of x with x, with the x at the back. Now, since we can express it like this, or let me put it like this. If we have y equals to fx, we can say the y dx will be equal to this. Anyhow we do it. In the same way, we can say this. Yes. You can see. So, assuming x is changing with time, y also changes because of the relationship between the two of them. We can then say the y dt is equal to fx dx dt. Just like we have a parametric equation. Do you understand now? We can relate the two. Sometimes it might not be direct like this. It might be more, it might involve more work than this. But have this in mind. Okay, let's look at another one. If we have z equals fx gx. You understand? It means that if this one changes, this one will change, and this one will change at the end of the day. And sometimes this might be constant, and only these two will change. So which means that maybe when this one goes up, this one goes down, one way or the other. So just have the picture, have the thing in your mind, create the picture in your mind. So with this now, assuming this one is also a function of x, as it will change. So we can now say the z dx will be equal to fx g. Okay, let me put it like this. The gx dx plus gx dfx dx. Now you can see how it is now. You can see how it is. Now let's look at something like, if this one is changing with time, and this one is also changing, and all these two changes with time. So we are going to have something like this. This is dx dot dx dt. So you can see, all these ones will also change. It might not be as direct as this. Sometimes, the change of this, total change of this, will depend on absolute change in the two functions. So, by the time you look at one or two examples, you will see how this relationship can take place. But it is about the change in one affecting the other. It is change in one that will cause the change in other. Or cause, yes, that will determine the rate of change in the other side. Now, let's look at an example. It says, if the radius r of a circle is 3 cm at a certain instant, and is increasing at the rate of 0.5 cm per second, at what rate will the area A be increasing at that instant? You see, we have said it, that, which means that when one occurs, it will cause, when one change occurs, it will cause change in the other side. Look at this. We have A, and you know the relationship between A and R is pi r squared. You can see. Now, you know one thing. If A increases, let's say if A increases, if R increases, sorry, R will increase by this. You can see, automatically, A plus delta A is going to be pi into R plus delta R squared. You can see. So, which means that if any change occurs in this one, change will occur in this one. That is what we are talking about. Sometimes it might be two entities, it might be three. That will cause the final total change in this one. Now, since we have known what the question is talking about, let's work it out. We know that our R is 3 cm. The RDT, that is the rate at which it is changing, the RDT is equal to 0.5 cm per second. can calculate our dr, dA, dt. And what is the question? The question is asking for dA, dt. Now, let's proceed like this. What is dA, dr? You can easily find that. Pi into 2r, which is 2 pi r. And we can work this out by saying dA dt will be equal to dA dr times dr dt. You remember the chain rule? And what is dA dr? 2 pi r. What is the r dt? 0.5, which is pi r. What is our r? 3 centimeter. 3 pi cm squared per second. So you can see, it is very easy. Always try to look at the chain that will give you the final answer. That's all. Okay, we have another one here now. It says a hollow right circular cone has base radius 4 centimeters and vertical height 20 centimeters. It is set upside down with its axis vertical and contains water. Water is being added at a constant rate of 1.5 centimeter cube per second and leaks away through a small hole at the vertex at the rate of 2 centimeter cube per second. At what rate is the depth of the water changing when the depth is 12 centimeters? You know, I tried to show you what it will be like. For instance, we know the formula of the volume. They are asking us at what rate is the depth of the water changing. You know the relationship now that volume is equal to 1 over 3 pi r squared times. And not only that, we will try to make everything to be in terms of h, so that the total differentiation of this will contain everything here. How do I mean? This r2, if we can find it in terms of h, so that because the change as the height is changing, the radius is also changing. So because the two changes, the change in volume will be determined by change in r and change in h. So it's either we can find the r dt, the h dt to determine the v dt, or we find the v dt, the r dt to determine the h dt. If that might be cumbersome, we might express r to be in terms of h, and from there we can find the whole thing. I was told that this one comes like this. From here to here, you can see this base is 20. And we are told that this place is 4. You can see. So we can easily relate these two now. Now we are told that the water, there is water up to 12. So we need to find this place, r here. Do you understand? We need to find r at this point. So we can say, before we go on, we also told that water is falling at the rate of 1.5 centimeter cube per second, and it is leaking away at the rate of 2 centimeter cube per second. So which means that the overall happening is leakage, because the quantity that comes in is lesser than the one that is going out. So total change in volume per second is equal to 1.5 minus 2, which is minus 0.5 centimeter cube per second. Yes, we have gotten that one at the same time. Now, let's find out at the points where the water is leaking. So we have 4 over 20 is equal to r over 12. Therefore, r is equal to 4 times 12 over 20. This is, let me make this one 10. So which is 24 over 10. It's 2.4 centimeters. So r at this point is 2.4 centimeters. Now, we know that v, volume, is 1 over 3 pi r squared height. Let's look at something here now. What is the relationship between this one and this one? Therefore, h is h over r 20 over 4. So h is equal to 5 20 over 4r, which is equal to 5r. You can see that now. So from this one, we are able to get h, the relationship between h and r. That's what I was trying to say. So that we don't need to start working out what will be the rate of change with r, and then we start finding it again. Therefore, v will be equal to 1 over 3. Okay, so r will be equal to h over 5. So 5 times h over 5 squared times h. Because if we do not do this, we need to start looking for what will be the r t. Then you can see. So v will now be equal to 5h cubed over 75. You can see now. Let's now work out the v, the h. The v, the h. So the v, the h is equal to 5 over 75 times 3h squared, which will be equal to 5h squared over 25. You can see now. Therefore, how is the depth of the water changing? So we can now say dv dt is equal to you can say the h dt is equal to the h dv times dv dt. You can see, very easy and straightforward. So the h dt is equal to what is dv dh? So the h dv is 25 over 5 times 12 squared. What is dv dt? Minus 0.5. So you can see. So we are going to have 0.5 times 25 over 144 times 5. And that's going to give us, please note, this is minus, which means that the height is decreasing, which is minus 0.027 centimeter per second. So please, you can see, the height is reducing, in spite of the fact that they are adding water to it, but the rate at which it is leaking is higher than the rate at which water is coming in. So please, I just want you to know that this thing is very simple. But when you have any variable, no matter how many, ensure you express the whole equation in terms of the one you can get the rate of change. Like what we did here. Because we don't want to start finding the rate of change of r. Because r will change when h changes. That's why we express it in terms of h. Is that clear now? Thank you. So, this is the place I'm talking about. And I did that from here. Let's look at another one. Let's now do this. The question says, a 17-meter ladder is leaning against a building. The foot of the ladder is 8 meters from the base of the building. It is sliding away from the building at 3 meters per second. A. How fast is the top of the ladder sliding down the wall of the building? B. How fast is the area formed by the ladder changing at that distance? C. Find the rate at which the angle between the ladder and the ground is changing at that instance. We have some information here. The length of the ladder is 17 meters. And the base of the ladder, the foot of the ladder is 8 meters from the base of the building. So let's call this place the building. And we have this. This is the ladder. And this is the base or foot. Therefore, length of the ladder is constant. That is no problem. So we have this, let's call this place x. Let's call this place y. That is the vertical height of the wall is y. and the base, the foot of the ladder from the wall is, let's call that place S. Now we are asked to find the rate at which the ladder is sliding down the wall when this one is moving away at 3 meters per second. I said something. Okay, before I say anything, the relationship between y and x can be gotten using Pythagoras theorem, because this one is constant. So y squared plus x squared is equal to half squared. So using Pythagoras theorem. X squared plus y squared is equal to half squared. So that one is okay. And I said something. When you are doing this, as much as possible, work it out in such a way that, okay, let me do that. Now, let's differentiate with respect to x. We have this one to be 2x plus 2y divided dx equals 0. You know this one is constant. Therefore, 2x is equal to minus 2y divided dx. So let's divide both sides by minus 2y. So we have 2x over minus 2y is equal to minus x over y is equal to y dx. Making it very simple. That's what I'm trying to do. But one thing is happening here. We are asked to find dy dt. And we can do that by saying dy dt is equal to dy dx times dx. And what is dx dt? We have been told dx dt is 3 meters per second. That is the rate at which the foot is sliding away. It is positive 3 meters per second. Therefore, dy dt will be equal to minus x over y times 3. And please take note, we have not gotten the actual value of y at this point. So we can still get it using Pythagoras theorem. Let's go ahead and do that. To find y. You know that x is equal to 8. You can now say 17 squared is equal to 8 squared plus y squared. Therefore, y squared is equal to 17 squared minus 8 squared, which is 225. Yeah. So y is equal to 15 meters. With this information, we can get our dy dt. Therefore, dy dt, that is rate at which y is sliding, is minus 8 over 15 times 3, which is minus 8 over 5, minus 1.6 meters per second. So we have gotten that. Minus 1.6 meters per second. So what does this mean? It means it is sliding down. And we ask that how fast is the ladder sliding down the wall? So that's going to give us 1.6. You understand? And if we ask how it is sliding up, but it is sliding down at last, we will put minus. So the rate at which the ladder is sliding down the wall is 1.6 meters per second. I believe you understand what I'm saying. It is sliding down, so we don't need to put the minus again. Thank you. So we go to the second one now. Now asked, how fast is the area formed by the ladder changing at that instance? We can easily do this using this information, or we can do it using this information and other ones alone. So now let's look at it in these two ways. Area is equal to half base times height. And what is our base in this instance? X. What is our height? Y. And if we want to differentiate A with time, you can easily do it by saying the A dt using product rule is equal to half into x dy dt plus y dx dt. You can see, you get it better when you get to partial differentiation. X dy dt plus y dx dt. And we know what our dy dt is, minus 1.6. Now, assuming you have not been asked to find the y dt before, we might be confused. You understand? But you must know something, that anytime you are finding something like this, every other thing changing, you must work them out to, to include just the constant and the one that the rate of change, and the one that is rate of change. Like there is relationship between x and y. Whenever x changes, y changes. So get the relationship between x and y so that you can use that rate of change of x alone. Let me show you what I mean. Now, you know that a equals to half xy and y is equal to root of l squared minus x squared. So we can also express a root l squared minus x squared. So you can see y has been expressed in terms of l and x now, and l is constant. Now, let us now differentiate with respect to. I want to express it like this: half root x squared l squared minus x raised to the power 4. You understand? You can use product rule, you can use logarithmic differentiation, anyhow. But I want to do it like this to make it fast. Now, I can now say a equals to half root u, half u raised to the power half. You understand? So, I can now say the a dt is equal to the a du times du dx times dx dt. The a du times du dx times dx dt. You know what we did here now? For this one. And then we get that. Or you can first of all see the a dx. And after you have found the a dx, you now do the a dt to be equal to the a dx times dx dt. So either way you like, you can do it like this way. Is equal to x squared l squared minus x raised to the power 4. So we can say du dx is equal to 2x l squared minus 4x cubed. You can also express as 2x into l squared minus 2x squared. So that is du dx. We have found that one. And we can say the a dx is equal to half times the a du. And what is the a du? Times du dx. You know share rule now. So which is half. What is the a du times half into u raised to the power half minus 1? U raised to the power minus half. And what is the u dx? We know it into 2x into l squared minus 2x squared. So you can see it is now very easy to handle. So u is this. I'm using this one to explain the differentiation. The u dx is this. Just differentiating this. Now the a dx is half, this half, times the a du, this one, times the u dx, this one. And this is u raised to the power half. So now let's finalize it. So the a dx is equal to 1 over 4 times, what is u raised to the power half minus half? That is 1 over square root of x squared l squared minus x raised to the power 4 times 2x into l squared minus 2x squared. So we are going to handle this a little bit. Fine now. So it's going to be 1 over 4 times 2x into l squared minus 2x squared over x into root of l squared minus x squared. I hope it is clear now. So this one I brought it in and this one came. So this one now becomes, and it's giving me l squared minus 2x squared over 2 into root of l squared minus x squared. So this is the a dx. And we know we have gotten this now. So our you can get it now. Assuming you just have one, you were not asked to find y before. This is how you go about it. Or you use your own initiative to find y. Is that clear? Now let's quickly do the third one. So about this differentiation, you can do it anyway. In logarithmic products, or I told you I do like it, I expand, and then from there it makes it easy for me to do. Now the last part is find the rate at which the angle between the ladder and the ground is changing. At that instance, you know we have so many trigonometric ratios we can look out for. This is the angle they are talking about. It is changing as this one is sliding, you know. So we can say cos theta, because for me, cos involves this one and this one. If you use tan, it will involve these two changing parts. But this one is not changing, so I prefer to use cos. If I use sine, this one and this one is changing. So assuming I have not found that of y before, it will give me any. But since this is the parameter given in the question, I like going with that if possible. You know. So let's do this. Cos theta is equal to x over L. And I can now say, let's differentiate both sides. I can now say minus sine theta is equal to 1 over L dx dx theta. Now, I can now say minus L sine theta is equal to dx dx theta. And the theta dt can be taken as the theta dx times dx. And what is the theta dx? 1 over minus L sine theta. What is the x dt? 3. Now, I can now find the value of sine theta. Sine theta is equal to this one over this. And sine theta is going to be minus 1 over L times y over L. I don't need to start working it out again because I've gotten it before. Times 3, which is minus 3 over 2. See, this one cancels this. So it's going to be minus 0.2 rad. You know we talked about it. When you are doing differentiation, the angle you talk about is rad. So the answer is 0.2 minus 0.2 rad per second, which means the angle is reducing. Another way you can look at this. Let's look at it. I have this cos x over L is equal to theta. So let's differentiate with respect to x. So this is going to give me the theta dx is equal to, you know, minus 1 over root of 1 minus x over L all squared times, I will differentiate this part again, 1 over L times 1 over L. So this is how you do this one. So which is going to give me 1 over L times minus 1 over root of L squared minus x squared over L squared. At the end of it, it's going to give me minus L, because this one comes out to be L, note the excursion, over L times 1 over root of L squared minus x squared minus 1 over root of L squared minus x squared. So that's the theta dx. Now let's find the theta dt. The theta dt will equal to, theta dt will be equal to theta dx times dx, which is equal to minus 1 over root of L squared minus x squared times 3. And we know this one to be 15. We have already done that before. So it's going to be minus 1 over 15 times 3, which is minus 1 over 5, which is 0.2 rad per second. So you can see, even this one is shorter. You can do it anyway. Just think it out. Go about with your differentiation. Be confident. You get your answer. So we continue later on in the next segment.